there are many algebraic properties and principles that go into doing what we're going to be doing this year. Some of these are just some of the properties that we're going to be talking about. Make sure that you can see them, and as the book uses them, or you hear them, or you see them in assignments, or talk about them in conversations in class, that if you don't know or can't recall them, you have a place to go back to. So we've got these, the most common ones, not all of them. The associative is one of those things. It's like, associate. Who do you associate with? Think of it like peer groups. And as long as how you associate doesn't change your identity or your value, then that fits into the associative property. So in this case, a plus parenthesis 3x minus 2. So right now the 3x minus 2 are associating with each other because they're inside parentheses. This down here, we've moved the parentheses to be around these two. Now, if the parentheses somehow got removed, maybe there's some other property, something else going on, as long as these two are the same value, which they are, then this is an example of the associative property. You can rearrange and reconnect and reorder them to be associated with other parts and pieces. We look at this one, a minus 2, or minus parenthesis 2 plus 3x, and then we moved the parenthesis to the first two. The problem here is, though, this first one and the second one are not the same. Because what's really going on in that first one is that I have a negative that becomes a, so I'm subtracting the 2, and I'm also subtracting the 3x because I'm subtracting both of the things inside. And that is very different than what this bottom one ends up becoming if I were to just move the parentheses. So with the associative property, you can't just move the parentheses to get what you want and call it associative. They have to be identical in value, and these are not identical in value, not the associative property. Commutative property, to commute, to move around, so just moving at different locations. So we have 14, 7x, negative 2y, moving them around. The value is still the same. So therefore this works. What we're careful of and watching for, though, is making sure that if it's a negative, that travels with the coefficient and variable that it's associated, that it's connected to. So that negative is part of the 2y, so it's negative 2y. So down here it's also negative 2y. This does work. When I have parentheses, you can't just move things around, much like we had with the associative property. This is not the same as the top one, because it would be minus 2y and minus 14, and this would be positive 2y minus 7x and minus 14. You see all sorts of things happen when you start moving things around. You're going to learn, if you haven't already, very, very cautious with our negatives, keeping track of where they go and where they belong, and when they're connected to parenthesis sets, that I'm making sure I distribute that the right way, which gets us to the distributive property. We've learned early on that when there is no operation in between two things, like this case, we have the 2 and the parenthesis set, that it's implied multiplication, which means everything inside the parentheses is going to be multiplied by 2. And the old school way of doing it, and let me show you that, would have been to say, when you did multiplication way back in the day, some of you did, it would be 7y minus 2 times 2. So we go 2 times a half, so that's going to be negative 2 halves, and then 2 times 7y, which would be 14y. It's the same thing, a distributive property. Oftentimes when you see it in an algebra class, they're going to distribute this there and to here. And what we're doing, we're distributing it through multiplication. So it's 2 times the 7y and 2 times the 1/2. So I'm going to have then 14y minus 1. I'll just go ahead and reduce it because 2 times a half, or 2 halves. How many is 2 halves? I have a full 1. In this next problem here, there's a negative out in front. And when there's just a negative and no number, it's an implied 1. And then we will distribute that. And negative 1 times 1/3 is negative 1/3. Negative 1 times negative 4p. Negative times a negative is positive 4p. The multiplicative identity is one of those properties that we're going to be actually using quite a bit, although it doesn't look like something really fancy. If I have m times 1 and I do that, I'm still going to get m. But what I did here is I changed my 1 to a 3 over 3, because 3 over 3 when you reduce it is 1. So m times 3 over 3 is technically still m, although we would usually write it as 3m over 3. And how we're going to do this is, say I have a fraction, something like negative 3 halves, and I want to convert that into 18ths, something in the 18ths. I would multiply this fraction on the left by 9 over 9, because 9 over 9 is 1. And when I do that, 9 times negative 3, I get negative 27 18ths. So maybe I need that to get common denominators, something along those lines. So the multiplicative identity is actually something we use quite often when solving problems and working through, and specifically when doing fractions. We've got the multiplicative inverse. We're going to use this a lot in solving for algebraic equations. 3 times m. The multiplicative identity inverse of 3 is 1/3, because 3 times 1/3 is 1. So I'd left with 1m. If I have negative 4/3 r, what would I multiply that by to get r? As you looked in the previous example, it's going to be the inverse. Now, when we say inverse, what I'm really talking about there is when you take that fraction, you flip it upside down. So then that would be 3/4. All right. And I need the result to be a positive 1 when I multiply, so I make this also a negative. So if I were to multiply that out, negative 4/3 times negative 3/4, I would have positive 12 over 12, which is 1. Lastly, the additive identity, pretty boring here. But if I have a value and I add nothing to it, I still remain and keep it as that same value, the additive identity. What have I added to it to keep it the same? I've added nothing. Not quite the most exciting principle and property in algebra. So there it is. Best of luck.